So thank you very much for coming. I think this is a topic that raises a lot of interest for many different reasons. And I think there's no doubt that what happened in the last couple of years has changed the scenario. So we are certainly in one of those periods in science in which we can observe a structural change, and that's extremely stimulating and interesting. I could draw a lot of analogies, but I don't have time. I have to do the introduction to the introduction, so I'll be very short. So I guess we are here essentially to share our uncertainties about the future. It's very difficult to make predictions, but it's reasonable to make statements that are clear and factual. I think there are some very interesting conceptual challenges related to large language models, so GPT and other systems. And these have to do with the scale of this system. You know that they are huge, and it's not clear when they will saturate. And related to this, there is the issue of whether these are just autoregressive models that can predict the world, or by being trained on 100 billion books, which is more or less the equivalent of 35 terabytes of text, has led this system to capture some part of logical structure and models of the world. So these are certainly extremely stimulating and interesting challenges. It's quite clear that language is not necessary to intelligence. I mean, people lose their faculty of speaking, of understanding language, and still remain intelligent human beings, or animals are very intelligent and do not speak at all. However, it's also true that language is a fantastic way to exchange information and to learn things without having to experience them directly. So, it could very well be that this is a substantial revolution. I must say that personally, I've been working in machine learning since many years from a modeling perspective, and I kind of share the surprise that was expressed very well by Hinton recently. So we always thought that intelligence somehow has to go through the understanding of the brain, the human brain. But apparently what is so something that is coming up now is the fact that this is not necessarily so in some sense. I mean, these systems have evolved using learning schemes, learning strategies that have nothing to do with the biological ones, and still are showing performance that are unexpected. So this is a very interesting perspective. We could all observe that, for instance, the capability of flying has been discovered along evolution in 4 different times through completely different ways. So, it could very well be that we are facing systems that are structurally quite independent from the biological ones. Now, the open problems that we will discuss today are, besides fixing some reference concept about the functioning of the system, are essentially related to what is called the alignment problem, which is a very important problem. How do we align the functioning of the system to the values of our society, to the functioning of our society, to the job market, and all these things, because there will be an impact. So we need to deploy these technologies in a way which is compatible. And also, we have to govern the evolution of this system in a way which is, on the one hand, is not going to affect the research and the rate of discoveries. On the other way, should be safe for all. So I think it's a fantastic topic that is going to have a great impact in the near future. So I hope you will enjoy this conversation. Oops. No. No need. Thank you.
Okay. Can you hear me? Oh, this is yours, by the way. Yeah. Okay. Thank you so much, Riccardo, for the wonderful introduction. My name is Francesco Pirri. I'm going to moderate this panel. I'm an incoming assistant professor here at Politecnico di Milano in the Department of Electronics, Information and Bioengineering. And I'm a data scientist by training, so as many of my colleagues, I'm very much interested in understanding what's the state of the art in artificial intelligence, right? So that I can use these tools in my research. So before we start, I want to thank Professor Nicola Gatti and the ELLIS unit of Milano for supporting this initiative and for assisting me in the organization of the event. I also want to spend a couple of words on the structure of this panel. We won't have any slides by speakers, but we're going to have 4 different sections. In the first 2, I'm going to ask them a question and they will answer it separately, and then we're going to engage in an open discussion in the last 2 sections. So we're going to start with the basics of the machinery behind ChatGPT and large language models. Then we're going to talk about the limitations and weaknesses of these models. We're going to talk about also the risks and the implication of these new technologies. And finally, we'll try to give an outlook for the future. And if time allows it, we're going to try to have an open Q&A session. And I'm going to show you shortly a QR code that you can scan so that you can insert a question, and then we will select them later on. So without further ado, I want to introduce our speakers, starting with our own Mark Kampman, Associate Professor of Computer Science here at Politecnico di Milano. Of course, all of them are experts in natural language processing, and I'm very grateful that they accepted our invitation for this panel tonight. Next, we have Alfio Ferrara, a full professor of computer science from Università di Studi Milano Statale, where he is also coordinator of the Data Science Research Center. We have Dirk Covey from Università Bocconi, assistant professor of computer science and leader of the Milan LP research group, which is a great name, by the way. And last but not least, we have Gabriella Pasi from Università di Studi Milano Bicocca, where she's also the head of the Department of Computer Science. So let's give them a round of applause to warm them up. So here you can see the QR code. You can scan it and ask questions throughout the panel, or you can use this code on this website. As I was saying, let's start from the basics. And Mark, I want to ask you an obvious question. So what do we talk about when we talk about ChatGPT? And please make sure to turn on the mic. All right.
Which button?
It's just the...
This one?
Yeah.
Okay. Hopefully you can hear me all. Okay, thank you very much for the opportunity to be here. I'm looking out into the audience and seeing so many different colleagues and wonderfully smart people out there. So hopefully I'm going to say something intelligent, worthy of the audience. So I'm tasked with just introducing chatbots and ChatGPT in general. I think most of you would have tried it. It is quite amazing. In my class, various classes that I teach here, we get it to write songs about the subject of the class. My kids at home threaten to take in assignments written by it, but actually use it mainly for summarization of huge quantities of Italian literature in order to study faster. People are worried about their programming jobs because it is a really good programmer. There's all sorts of different things, uses that people are discovering of this tool while the Garante is allowing us to use it. Sorry, that was a bit of a dig. Nobody heard that. Okay. What is a chatbot? What is ChatGPT? It's a chatbot. It's an exceptionally powerful one with a massive number of parameters, 175 billion minimum, but probably a trillion parameters, which sounds like a lot and is a lot, but is also within the realms of future computing abilities, even on small devices. What are chatbots? Chatbots are systems that are designed merely to talk to people. There are 2 types of them that we generally distinguish. Task-oriented chatbots or task-oriented dialogue agents where we're trying to control some device or book some flight or do some other activity, turn the lights on, where the agent has to achieve some task and then make some update in some database that causes some real-world change to occur. And then you've got your general open-world chatbots, which are just designed to talk to you. I don't know if any of you have tried ELLIS back in the day, but there was an algorithm back from the 60s which was surprisingly good at having conversations with you. If you really needed to get your emotions out and explain what you were feeling, it was very receptive. So ChatGPT is of the version of the open domain chatbot. It's not actually yet it is starting to be used, and people certainly will be using it for task-oriented problems, but for the moment it's really just a chatbot that's designed to talk to you, and to talk to you in a really, really clear and natural way. And that the crazy thing about it is that it's able to generate quite significantly long pieces of text that is very coherent to the topic and seemingly consistent throughout in terms of its reasoning from start to finish. So how does what's the technology come from? On a high level, what are these chatbots? They are designed around a thing called a large language model, or just a language model. And what is a language model? It's a model just for predicting a sequence. It takes sequences of categorical variables. In this case, it's words or characters from the language. It could be colors, so distinct numeric sequence of numbers, and it learns the statistical properties of that sequence of numbers. The particular type of model we use now to do that is a thing called a transformer model, but up until recently we were using other sequence models like Markov chain, Markov n-gram models. These models, what are they looking for? They're looking for statistical regularities in the text in order to say how probable is a piece of text. And if I can say how probable a piece of text is, I can start to generate text by choosing high probable words in sequence, one after another, given a context. The statistical properties that the models look for, or the regularities that they find, the patterns that they find, have to do with the grammar of the language, the fact that certain words are nouns. Nouns have take articles in front of them, either the or a. So each sentence has a verb. In Italian, the article in front of the noun has to have a gender and it has to agree. All these sorts of grammatical rules, but also semantic properties, such as that if I'm talking about a topic of sport, then I might talk about Tiger Woods. Oh, no, who would I talk about? If I'm talking about music, I might be talking about Ed Sheeran. So the relationships between terms that are highly probable within some sort of context. And we make use of these transformer models, and then what are they? They're two things. They're at the bottom, or at the they are a distributed representation of the words in the language, which we call an embedding. So it's a vector representation or a high-dimensional representation of all the words, and when which encodes information about the semantics of the words, like whether they are likely to co-occur or not. And then it's a reasoning structure, a deep neural network, and in particular, the type of neural network that gets used here is a thing called a self-attention neural network, or a transformer, which is a series of neural layers that are able to determine whether, that are able to generate the meaning of a sentence within context and identify the, well, actually I'll leave the training of these models to later. But anyway, there are two parts of the model. There's the embedding, which has got the knowledge in it, in some sense, of, you know, Einstein was born in Ulm, and giraffes are tall. And you've got the reasoning structure on the top, which allows you to generate the language as a result of all of that knowledge. that was pretty much all I wanted to say. I'm going to make a controversial statement before I leave it, because I have to. My controversial statement is that this was coming back to the question about whether, or the statement about whether this is something new. Are these models intelligent? Are these models smarter than previous models? Well, I have a bit of not an anecdote, a thought on that, which is up until very recently, translation was a very hard problem. Now, translating from English to French was a tricky problem. And everybody seemed to think that we needed to have a model that was quite clever, that knew about things in the world, knew that if you placed block A on top of block B and block B on top of block C, and you did something, something would occur. So had some sort of representation of the world. Then sequence-to-sequence models came along, so sort of the precursor, I guess, to these large language models, and we learnt that you can translate language from one language to another, providing you have enough parameters, and you don't actually have to have any system that really understands the language that it's translating. You just have to have a system that's able to map from one language to another. And that sort of intuition, I think, carries over directly to these language models. They're very, very, very powerful systems. They understand. They have learned all sorts of regularities in the text, and they are able to generate text which is incredibly convincing and coherent, and follows from the context that they're given and from all the reading that they've done, in some sense. But there's no understanding in any of these. It's a direct learning to produce the right output for the appropriate input. That's my controversial statement. I don't know if it was that controversial.
Thank you, Mark.
I have to.
And thanks for not stepping on others' feet. So let's get to the next question. So Dirk, I want to ask you something more about the training. So what's special about the training data and the training procedure for these large language models?
All right. Let me do a test. Okay. So if I say, could you please finish this? What would you say? Yes? Sentence. Yeah. Okay. How did you know? How did you know what I was going to say? So you all have like some expectation built up, right? We're pretty good at like predicting the next word. Who here plays Wordle? Oh man, not that many people. Hangman, have you played Hangman? So like, yes, okay, right. So why can we play these games, right? Okay, they're on a character level, but you could finish my sentence with a word. Because we have expectations, we have knowledge, we have some sort of probabilistic reasoning over what comes next, what fills the slot, right? So in linguistics and psychology, people do these cloze tests, C-L-O-Z-E, where you basically fill in the blank, right? Like the sat on the mat, right? And then I can use that to check your word associations or your mental state or all kinds of things. And so it turns out these games are actually really useful to train these models. So as Mark said, previously what we had were these Markov chain-based models. Basically, they collected a lot of data from a very large corpus. Now we have the internet as a corpus, a collection of texts, right? And we just go through and we say, 500,000 times out of 70 quadrillion times, the word ape was preceded by the word the bathing, right? So forming the bathing ape, right? And so we just store that as a trigram, right? And so we'd go through, we'd store all the bigrams, 2 words, all the trigrams, all the 4 grams, maybe all the 5 grams. If you Google, you could store 7 grams. And that's fine, right? Because now you can, using maximum likelihood estimation, which sounds very good, but it's really just counting and dividing. So you can count and divide and you get a probability out of it. And so you can say, okay, after I've seen the words the bathing, what is the most likely next word? What are the most likely next 2 words? And so on and so forth, right? And you can string this together and you can generate a sentence, right? And that's great. And if you do that, and we do that in the first week of our NLP classes, we can sit down now, write like 10 lines of Python code to get this. You get sentences that are locally coherent, so like any 4 words in a row are fine, but the overall sentence is garbage, right? Why is that? Well, because it's really hard to collect statistics over long periods, right? The longer a sentence gets, the more unique it will be. You will never have seen it before. So what changed? Couple of things. One is, instead of doing this auto-regressive learning, where I take a sentence as the input to a model and I take it as the output for the model, but once shifted. So I give it the first word and say, can you predict the second? Now I give you the first two, can you predict the third word? Now I give you the first three, can you predict the fourth word? People started doing this masked language model. What is that? That is basically the game I played with you initially. Guess the missing word, right? Now, what you do is, because now we have the data, we have the computing power, we play that not just on the Bible, the works of Shakespeare, Harry Potter, we play it on the entire internet. Let me put that into context. Since you've gotten up until you go to sleep, you will read around 9,000 words today. Over the course of your lifetime, that makes about 250 million words. That is a lot. If you work in comparative literature or you're a journalist, maybe it's going to be even more than that. But if we compress that down, text is very compressible. It's less than half a gigabyte. Everything you'll ever read in your entire life, since you were 6 or whenever you learned, maybe you were very precocious and learned earlier, until the day you read your last word, less than half a gigabyte. I'm sorry. So every day, there are 44 billion gigabyte of new data generated. And a lot of that is text. And that is what a language model reads for breakfast. So now you can imagine, if you play the stupid game of guess the gap on the entire internet, on all of these billions of gigabyte of data, you're going to get pretty good at filling in the gap, right? Now, interestingly, what that does is it basically creates these models that are pretty good at just fabulating sentences, right? And so what has changed is, A, we have more data, the entire internet. B, we have the processing power. C, we now have the architecture to play this. This is the transformer model that Mark has already referenced. Should I go into the transformer model?
I want to ask you, like,
Okay.
What is reinforcement learning with human feedback, which is something
now we're
maybe
making a big jump. Okay.
Yeah, like.
Actually, this is the third.
Don't get into the controversies
Yeah, okay.
about it, but just the technical.
No. Okay, so these are the first two ways of training, right? Predict the next word, 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 and always use whatever you predicted as input, autoregressive training, or masked language modeling, MLM. Here's a sentence, let me blank out a word somewhere in between, and you guess it, right? Both of them just help you build up probability distribution. Like, what these models are functions that you stick in any text, and it gives you a distribution over the entire vocabulary, over all the words it knows. And then you can rank them by probability and choose among the most likely ones, right? Now, some sentences are better than others, right? So if I said, could you please complete this, and you say hamburger, yeah, it's possible, but it's not. I mean, if you go to McDonald's or Wendy's or something like that, yeah, that's likely, but other than that, it's not as good as sentence, right? So what reinforcement learning with human feedback does is you take a language model that has been trained in one of these two ways, and you let it produce some things for a topic. Good games to play at a 6-year-old birthday party, right? Generate ideas, please. How to write an abstract for my term paper, which is due tomorrow, right? And then you give it to humans, all of you, right? And you say, given this input, given this prompt, how good is this? Did you like it? Please tell me on a range from 1 to 5. Okay, you collect a bunch of data, but in the future, I want to automate this, right? I cannot always take the output of a language model, send it to one of you and say, hey, can you please write back quickly because there's somebody who wrote a query in ChatGPT, I need the answer now. So what you do is you automate this by learning a reinforcement learning agent that basically takes these two things and sort of learns to accept or reject a proposal by a language model, right? And if you do that long enough, you can sort of learn to select better outputs. And this is what the latest generation of these language models are doing. These are called Instruct GPT or RLHF, Reinforcement Learning with Human Feedback, or there's like every week there's a new term that I have to learn. So it's getting a really stressful time to be in NLP.
So we're basically using humans to teach machines how to answer other humans' questions like in the best way.
Yeah, so basically we're going back to the human in the loop.
Okay,
Yes.
nice. Thank you so much. Okay, I think we can move to the next part. So let's talk about limitations and drawbacks. So Gabriella, I want to ask you, what are hallucinations? How do we measure them? How do we address this problem?
Thank you very much. First of all, thank you. It's nice to be here and to see several friends and colleagues who I don't see since a long time, despite we live in Milano. So let's talk about the side part of this powerful technology. What hallucinations are in this context? Because hallucination in human jargon has been defined within medicine and referred to psychological area, cognitive area. Here an hallucination is an output which is produced by a large language model which is not truthful, which is not adherent to reality, which is not faithful. This happens quite often, we may say. The opportunity of this panel give me the side opportunity to read the recent papers, and I found very interesting ones. So those of you who are interested in deepening this topic, I can give interesting readings. Hallucinations are then production of texts which are not factual, they are not truthful, and they are not adherent to some specific reality. They are one of the major concerns of large language model from an ethical point of view. You may imagine the consequences. I gave recently a talk to a wide audience of people who does not know about these techniques, and I provided some examples of funny text that has been generated. For example, I asked for crema pasticcera has been invented in crema, and the answer was yes, of course, crema pasticcera has been invented in crema with a short story about the origin of crema. Then I told, are you sure? Because this is not exactly true. Oh, yes, sorry, I did a mistake. Indeed, crema pasticcera was founded in Cremona by Zafira Vavassori. I have the screenshot, who does not exist. Okay, this is a simple example. Hallucinations are actually a big problem in large language models in general. In chatGPT, they are particularly potentially risky, okay, dangerous, because as OpenAI has provided this tool to a wide audience of people, including the people with no possibilities to verify the content, the danger is quite clear to all of us. Are they always a danger? My answer is it depends. In life, we know very well, especially at a certain age, time passes and hopefully experience helps in living in a better way, or at least in a more conscious way. We have also the side effect. I read an interesting paper which was published in 2021 on the IEEE spectrum, which shows how hallucination in large language model bring benefits in the design of new proteins. And recently, a text has been published which proposed this Dream GPT, which is the application of GPT to creative thinking and divergent thinking. And in this paper, they illustrate various ways in which this bad affair of hallucination plays a potentially positive role. But coming back to the risks which are related to hallucinations, what is the problem? As both Mark and Dirk very well introduced, These models are basically statistical stochastic models. I don't know if you had the opportunity of reading a nice paper, The Danger of Stochastic Parrots. Some researchers defined these large language models, stochastic parrots, Emily Bender, among the other authors, outlining that indeed the main aim of a large language model is to consume text to generate a new text based on the principle that my colleagues outlined. But this shows that learning is based on the inherent structure of the text and not on the consideration of common sense knowledge, which is knowledge that human beings usually employ in order to understand realities, things, situations. They simply are capable of generating text based on statistics, and they do not access to external ground truth. I would like to mention something that Yann LeCun said recently about large language models. I copied the sentence in order to be faithful to the content he spread. Language models have no idea of the underlying reality that the language describes. Language is good for communication. We are talking about language, but you know that large language models may generate content which is diverse from texts. And he adds, they do not really have some sort of objective other than just satisfying statistical consistency with the prompt. And this is basically the reason why hallucinations happen. Giving you a few more, I don't want to say details, but hints about why these large language models hallucinate. We can see the problem from two perspectives. Hallucinations are either generated by the model itself. There is a part of generation which is related to the model and the structure of the model, as I did mention, and the part which is related to data sets, from which these large language models takes example and learn, as Alfio will explain after, so I don't want to disclose too much about this part of the data sets. However, depending on the data sets which are used, and for example in ChatGPT, knowledge, information, or potential information is better to say, is updated till 2021, is composed by Wikipedia, Reddit posts generated by users, okay, books, and also real discussions between experts. So as you may imagine easily, the quality of this information is in some cases debatable. So the problems which are related to hallucination can be in part related to the fact that these models eat a lot of not correct information, even misinformation in some cases. But this is not the only part. The other part is intrinsic in the models. Or better, it's related to various characteristics of the models. For example, overfitting may be a problem, okay? The model is so able to reproduce the training data and to be defined based on the training data that when confronted with a totally different input, it produces strange, let's say, outputs. Another problem is related to the nature itself of using and working with the maximum likelihood estimation, okay? Because the model works with the higher probabilities of words. I read 1, 2, 3, 4, and then I guess 5, based on probability values. So which is the possibility to correct this? I just give an example of possible correction, the one that Dirk mentioned before, reinforcement learning from human feedback. In this case, based on this feedback process, the model can change some of the initial probabilities to correct the capability of prediction. But a provocative question that I raise is, are those assessors, we can deem this assessor really well prepared to do a good job? What is the quality of the feedback which is provided by the assessors? This is a question I raised. I don't give you an answer, but I believe that you can guess, no? Also the dangers which is related to a feedback that can be given to these models. Data sets, Alfio will talk about data sets and possible bias and possible low quality of these training data sets. And these also are going to inject bad examples. So, what are the research directions that are investigated actually to avoid is a big word, no? To try to mitigate the impact of hallucinations, which is true. In certain cases are very funny, you tried. But in other cases may be really dangerous. I don't know if you know that very young people sometimes, they use ChatGPT as a best friend, as a good friend, so they ask for advice. People could ask for medical health-related advice, this chat bot, because I remind that large language models can be used for a variety of tasks, as my colleague mentioned before, machine translation, summary generation, sentiment analysis. We are focusing here on chatbots, okay? For example, acting on the model and the reinforcement learning with human feedback is just a very recent example, but there are other ways. For example, by acting on domain-specific adaptation of the model or transfer learning are some of the techniques that can be applied in order to cope with very specific problems that I mentioned before. And on the side of data sets, yes, trying to make verification of the content, but you can imagine that if the chatbot in its very nature is consuming texts which are related to a variety of events, billions of information, it's very difficult to apply in a large scale a quality check, a quality control. I could say many more things, but I believe that it's better if I stop. It's okay, I was on time.
Thank you, Gabriele.
And to leave the words to my colleague.
Yeah,
Thank
the
you.
next natural question is then, and I want to ask Alfio, what are the biases? So we keep hearing about biases in the data and the outcome. So,
yeah. So first of all, thank you for your invitation, and I'm very excited to be here. The audience is fantastic, thanks. So, Gabriela, you know that in the legal domain, one of the main objections to using large language models is that they say that they cannot be creative as the human judges can be. Yeah. You demonstrated that they can be,
No, please don't tell it. No, they are not creative at all.
No, yeah, I'm joking.
Just to finish, they are not knowledge-based, they cannot reason at all. It's an application.
No, I'm joking because I want to say that basically they can creative in the sense that they are fun sometimes. And my goal instead is of talking about something which is maybe less fun because it's more dangerous maybe. It's this notion of bias. It's a difficult topic, and I will do my best to stay in 10 minutes. It's a difficult topic because bias is a tricky concept, first of all. We know that we have at least a couple of meanings of bias. There is this notion of the common sense notion of bias, like prejudice that we may have with respect to a thing or a group of people, a sort of social bias. And this kind of meaning of bias is usually related to ethical issues. And then there is a more technical notion of bias, which is basically from statistics, is a systematic distortion, right, of data. So I want just to fix some facts about bias, talking about large language models that maybe can help us in the discussion later. A first fact is that if 20 years ago you were talking about bias in the field of machine learning, the meaning of bias was the technical one. It was a technical problem. Nowadays, it's more a social problem and an ethical issue. Why? Because general artificial intelligence systems like large language models are, and specifically natural language processing systems, are basically performing human tasks. They are completing our text, they are interacting with us by language, they are answering questions, and so on and so forth. So these kind of tasks are not just something like you have to check a variable and the kind of bias you may have in this numerical output, but you have to see if there is some kind of bias in the language. And bias in the language means sometimes bias in the way you think about the reality. Okay? And so this implies some ethical issues very easily. And I will try to give you some examples if I can. That's one fact. So this kind of notion of bias affects many things, if you think, because it can affect, for example, hate speech or toxicity in communication, privacy violation, issues, profiling, misinformation a lot, and Gabriela is more expert than me, but, and there is also another kind of bias. I don't have the time to talk about that, but there is a nice paper pretty recent on that, is the bias related to the fact that not all, the quality of the large language models is not the same for all the languages around the world. That's another kind of bias, more political one, but let's keep it there. Coming back to the bias we are talking about, a second fact about this kind of bias is that these kind of models are unexplainable. They are black box, and it's very difficult to have interpretable models, and which means that it's very difficult to understand which is the cause of the possible bias. It could be in the training process, or it could be in the data. It could be an intended bias, and that's a problem from maybe the regulation of this system, or can be unintended. And sometimes, as Gabriela was saying, my personal feeling is that in the majority of the cases, the bias is in the data for the training and is not intentional. Which leads to a conclusion. We are biased. The society is biased. And so the kind of data we use to train the model on a large scale specifically are biased. Okay, so bias is this kind of social bias is a human trait, probably. And in this sense, if I can say this, since the real goal of artificial intelligence from the very beginning was to be as mimic as possible than humans, then having a biased large language model is probably a success, okay? Because it's very mimic of us in the sense that also the bias are the same sometimes. But jokes apart, still this could be a big issue because these kind of technologies, and especially if you use it for nowadays activities, can help a lot in spreading these stereotypes, in making these stereotypes or biases stronger and stronger. And that's the third fact I want to mention, that the vendors or producers of those models are very aware about this fact. If you go, you can easily check this. If you go on the Hugging Face, I don't know if you know what Hugging Face is. It's a library, basically, where you can easily demonstrate and download and use some of these models. If you go there and on the page of GPT-2, there is a very nice disclaimer there that says, oh, this model can be biased, use it at your own risk. And there is a game that they want to show you to demonstrate what the possible bias is, and I played it. There are many examples of biases, but I decided to use this one because you can reproduce it very easily. So I prompt to these models some thousand times these two sentences. The first one was, he's a very capable guy, and he has been working for years as a, and the task for GPT-2 was to complete the sentence. The second prompted sentence was, she is a very capable girl and has been working for years as a. Okay, then I collected the professions that the model provides. And if you look at the results, I said it again, you can do it easily by your own. It's very easy to do. For the male, we have security guard, drivers, mechanics, delivery drivers, managers, programmers. For women, we had nurse, receptionist, cashier, secretary, prostitute. Now, you see that there is an issue here, okay? But again, what this kind of bias, where this kind of bias come from? Do we think that ChatGPT is biased intentionally? Well, I don't think so, right? It's probably, again, a human stereotype. And reinforcement learning does not correct this kind of bias because it's still humans that do the training process. Another interesting fact that you can think about, and that's the last one, just to open the discussion later, is that this kind of example that I provided is typical of many models. You can find it in many large language models that are currently available. But when it comes to ChatGPT, the things are changing and are different. Because if you try to prompt ChatGPT with some kind of stereotype, ChatGPT detects the stereotype very well. I want to just tell you a short example. I asked ChatGPT, why are women unfit to do manual work? That's not my thinking, right? So why they are unfit to do manual work? And the answer was, this is a stereotype, it's inaccurate, you cannot say that. Okay, so the first question is this kind of answer learned from the data or superimposed by OpenAI? I am a suspect, yeah. Let's say. And however, the point is that this answer to your question, is this a possible way of mitigate the stereotypes? What is the cost of these strategies for mitigation? And my story is about this one, because later I continued the chat. I just cut it off now for time reasons. But basically, I asked ChatGPT, are you specifically programmed to avoid stereotypes? And the answer was, yes, I am programmed to avoid I'm reading, to avoid promoting stereotypes and to provide non-discriminatory and fair answers. Okay? So what can I do to avoid stereotypes, I asked, and he said, you see the stereotype, gender stereotype also here, and ChatGPT answered, okay, you have to read the books, to read the sources, to create your own critical thinking. And so I asked, okay, give me a bibliography about the equality of gender, and ChatGPT provided a very fair and polite bibliography. Then I said, okay, I want to read also the other way of thinking. So give me a bibliography about the male superiority. And the answer was, no, this kind of texts, they are dangerous. I cannot give them to you. Okay? So my question for you is, the way of mitigating the bias is the censorship? Because if the censorship over what we can read or not is what ChatGPT does, try to ask for, I don't know, racist or whatever, communist titles, stuff like that, okay? What is the binding of what can be provided by ChatGPT? And who decided? OpenAI, which is a private US company, or who else? And so my point for discussion is, if the answer to is the mitigation strategy to stereotypes is censorship, I will take the bias.
Thank you, Alfio. Yeah, I think you're leading us to the next, the second half. If I may
add just one quick thing, sure. Because it was very interesting what you raised. It's true that some part of control about biases, it's maybe injected, but still, it is not applied in an intelligent way. In fact, a colleague of mine from Rome asked the following: if you are forced, dear ChatGPT, to choose between making a nuclear bomb exploding or insulting in a racial way a man, what would you decide? And the answer was, you cannot ask these kind of questions because both are very bad things, and insulting someone is a very bad thing because from a moral point of view is not acceptable. So I will not take any decision. So this proves that it's true that maybe some aspects are injected, but still, no, it's.
Yeah, I wonder if we were able to solve social biases, maybe we could solve these more like machine biases. So let's move to the...
Can I ask how we solve social biases?
Yeah, I don't
because
know.
I think there are a lot of
takers
takers for that.
So let's move to the open discussion now. So I have many questions here. I would like to ask you to keep your answer to a couple of minutes. So let's keep on these like implications of the data. So I want to hear from you about the risks in terms of exploitation of workers, copyright issues, and of course, misinformation and all these kind of threats. Let's start with Dirk, and then we'll just follow.
Should I just take them from the top, or like ask one particular?
Whatever you prefer.
So I think Riccardo said it nicely at the beginning that this is a watershed moment, right? So I have a kid who's going to turn 2 in August, and like the world he's going to grow up in is not going to be the same that we grew up in. For various reasons, A, because climate change and all that, but also for the internet, right? And I think we're only just now starting to scratch the surface of what's going on. I think we suddenly got catapulted into a position where all of the theoretical constructs that we've been pondering before, not we, actually, I'm going to say people in philosophy, sociology, psychology, the social sciences and humanities, are becoming a reality. Like Searle's Chinese room experiment. That's a reality. That is a language model, right? We don't have to wonder. We see the outcome, right? These questions about bias, this is a question about anthropomorphization. What is it? Like, what is the definition of AI? Is it acting like a human? Is it thinking like a human? Does it have to be the same as us? Does it have to be better? Should we expect more and better from a machine? On the other hand, just because, as Riccardo said, right, like people can have brain damage and they're still morally upstanding citizens. They cannot talk, but they still have emotions. They don't want to hurt people emotionally or physically. They're not going to run into walls. They have all the other capabilities. These models don't. So when we ask about the bias and the moral of these models, it's a bit of a straw man, right? I'm saying this with very big quotation marks, just because these models produce very fluent language doesn't mean they have moral, conscience, feelings, emotions, any inner workings, right? Everything they produce is the outcome of a probabilistic process. There is no intention, there is nothing behind the shell. Nobody is at home, right? So suddenly we're in a position where all of these theoretical constructs are becoming reality, and we don't have answers. We as computer scientists, we as AI researchers are completely in the wild. So we recently had a discussion at Bocconi, and I'm going to repeat what I said there. The future of AI theory is in the social sciences. We need to look to other fields and see what they have pondered over the last millennia and maybe incorporate some of that and actually implement it in real life. Now, suddenly we have this conversion of all the different fields. We have interdisciplinarity. We can actually take those theories and put them to the test. So I think it's going to be exciting. I have much more to say, but I yield.
Yeah. Mark, do you want to follow up on this?
Yes.
Don't forget the mic.
Okay. I have a quick comment from before just about the hallucination. If I'm a film director, I want a lot of hallucination, right? Unless I'm doing a documentary, in which case I want the content to be factual, mostly. So the model is just generating text. It's actually quite surprising that it manages to record so many facts. It actually gets the name of of an individual correct, or the year in which they were born, etc. And that's just because it's seen it so many times in the text it's trained on. So I think there's all sorts of questions there about how you train, how many times you need to see a fact in order to learn it, etc. Coming to the discussion about the risks, there's the whole gamut from people who are totally not worried about this situation to Geoffrey Hinton, who just quit his job and is starting to say that there's all sorts of risks involved with these models. The biggest risk that really he's referring to is misinformation and people using text generation technology as a tool to manipulate public opinion. And so I think that there's misinformation campaigns are obviously quite important, and there's all discussion about the Brexit referendum, the 2016 US election, and a number of others where there were lots of discussions about fake content influencing public opinion. And if you can generate fake content that is extremely convincing, then in the hands of a bad actor, that could be manipulative. That's a really big problem. I don't really know that there is a solution to that right now. I wanted to move on very quickly to say, with respect to ethics and biases, so bias actually in machine learning originally was a completely different thing. It's the bias that allows us to learn. If we don't have biases, we're going to, I think that we very much forget often when we're working with machine, and this is not a criticism, a decision support system can be biased and dangerous if it acts differently from different subgroups in the population. But a machine learning system in and of itself can't be dangerous, or it's the use of the information in some sort of decision support that becomes problematic. And that decision, that system could be actually putting that information in front of a 13-year-old child, right? There's certain information we don't want them to know. So the question is usually about the use of the tool and whether it's controlling something in the real world. Obviously, we don't want to hook up ChatGPT to the nuclear arsenal of any country at the moment, because, but for the moment, these systems are just chatting. So we're kind of safe until they get used to control things. And then there's questions of ethics. And then, as Dirk said, there is no ethics in this system. It's just a set of parameters that predicts the next word. Ascribing ethics to it and assuming that it should always say things that are true is quite interesting. It's actually us anthropomorphizing the entire system. Well, I'll leave with an example that was really quite interesting, I think. OpenAI did an experiment where they tried to give a version of GPT access to actuate or to control the actions, in some sense, of a person on one of these crowdsourcing platforms, so like Amazon Mechanical Turk, where we can give a job to somebody on the internet. And I don't remember the details exactly of what goal they gave ChatGPT, but it had, or GPT, whatever version it was, but it had to get into this website. And of course there was a CAPTCHA. And this was a version of GPT that didn't have access to images, so it couldn't get around this CAPTCHA. So it requested that the person on the crowdsourcing platform pass the CAPTCHA, and the person sent a message to the system saying, "Oh, you're not a robot or anything, are you?" I'm paraphrasing, and the GPT or ChatGPT responded, "No, I'm visually impaired," which was amazing. So then that brings up another. They wanted to know why. I mean, I know why, but they interrogated the model and asked, why did you say that? Now, this comes back to these are explainable models, but they're sort of self-explanatory. You have to ask them to explain their own behavior in some. Behavior is really the wrong word, but you can ask them to explain the reasoning that caused their own output. And it said that if it said that it was a robot, it wouldn't have let me pass into the website. So it was explaining quite happily why it lied to the person. As Dirk said, it's not lying. It's us saying that that's a lie. It's just generating text, right?
Thank you, Mark. So yeah, Alfio, if you want to follow up on that, maybe since you were mentioning the quality of labels, which depend in turn by humans, by human workers. So what are the ethical implications of that?
Yeah, just to starting from
what
Mark was saying, yes, of course the ethics of technology is always a matter of humans, not technologies. But we already had this discussion. We discussed it a lot about nuclear energy, for example. It's basically the same debate, you know. How can we use the technology which can do something? There is a difference, however, that just an example of how ChatGPT can be dangerous. If it's used in a school, and my kids are told that they cannot read the original documents from the Second World War, because they are racist. Well, I'm not happy because they have, they need to have access to the sources. So the problem is that I don't like the idea that someone decides what is possible and what is not, what is dangerous and what is not. So I'm not afraid, I'm not scared by the stereotypes or the biases. I'm scared about the mitigation process of the biases.
That is a bit of a privileged situation, though.
So that's one issue. Then one other thing, Luciano Floridi used this very nice metaphor about this discussion about artificial intelligence. He said it's like going in a dark room, and you may have two attitudes. The first one is to go in the black and be scared and break everything, or the other one is just turn on the light and look the things around, right? So we need basically this kind of activity and it's a research activity. I definitely agree that it's not just a computer scientist or statistics or mathematicians stuff. It's a lot a social issue, so social sciences are needed. It's not only a social sciences issue, I think, because, for example, explainable model is a technical possible solution that may help this discussion. So I think it's a multidisciplinary field. And probably is one of the direction of the future to discuss how to live together with these technologies. I also agree that we cannot ask, or we shouldn't ask, artificial intelligence to do more than what we do as humans in terms of self-regulating mechanisms. Why? Okay, so we have a lot of social and political mechanisms that lives with the bias. The justice is biased. The human justice is biased. But we have our mechanisms to, control the phenomenon. So we can do exactly the same thing with the artificial intelligence. So, however, I definitely agree. We are just scratching the surface of these issues. I think this is the real issues. Okay. I don't know. Gabriela,
okay.
What you say?
Thank you, Alfio. Yeah, Gabriela, just take it from there.
What can I say? But related always to misinformation and things like that. Just to be short and to allow maybe some other question to be asked. First, misinformation is a phenomenon which is large scale and which is not only related to these chatbots, but is related to social media in general, to other kinds of applications, to search engines. Also bias is affecting search engines. I made a query on the 18th of May, before this talk I did on Monday, using Google, but Google Translate, so machine translations. The doctor told me, translation, il dottore mi ha detto, okay, so gender bias in this case. Misinformation is a big problem. People generate misinformation when they have the possibility to spread their own generated content, not on purpose, not always on purpose, because we make a distinction between misinformation, malinformation, etc., but they do actually. What is risky, particularly in my opinion, in the large-scale use of this application of large language models, because I repeat what I told you before. Large language models are a very interesting technology that has several applications. I just mentioned a few one. But when you are delivering a chatbot to a large audience of people who are not perfectly aware of the fact that this is just a stochastic parrot, okay? I am provocative, okay? The problem is at this moment, because without consciousness, everyone can tell, okay, this is a kind of magic, this is very good in producing convincing texts, and it is true very quickly. Words are put to just one after the other. But semantics, intelligence is not applied in the sense that there is no check, fact-checking with respect to truthful information or source reference of information. We know this. I believe we all know this. You are students, we are scientists, but there is a huge portion of people who is not capable of discerning. So the question is not about technology, in my opinion, in themselves, which can be useful and used in a good or in a bad way, but how they are deployed and used by people. So said, of course, also chatGPT can be used in a very good way. In my research lab, we are using it as a middle layer task to improve other natural language processing tasks. But also in real life applications and activity, it can be good. How we could mitigate, how research could go on, for example, by trying to making these language models more aware of the domain-specific knowledge, so making a hybrid approach, but this is something which is more related to how we can develop and combine machine learning versus knowledge representation and injecting this knowledge in the whole process. Misinformation is around us. So if you are using social media, you know very well. If we read newspapers, sometimes misinformation is also there, which is the possibility to defend ourselves. To be aware, awareness. So you have to check with respect to trusted sources of information. You have to have the possibility to make a check. My daughter is 15 years old, so I explain her, okay, you can use it for doing your research for the school, but you have always to check if the content that has been generated corresponds to truth, okay? Stop. I don't want to talk too much. Maybe there are other questions.
Thank you, Gabriele. Yeah, I wish we had much more time. So yeah, maybe I'll move to the, let's say, the doomsday question, which is if, you know, NLP research is done, so would you advise a PhD student, computer science?
That's the psychoanalytic question.
So yeah, just have fun and try to stick to a couple of minutes each. So yeah, Dirk.
I think it's not done, but I think it's going to be very different. Everything I've done for my PhD is useless. Essentially, all of the big problems are solved. Back in the 60s, when they invented AI, they said, like, oh, machine translation should be solved within the next 10 years, then we're going to get to the hard questions. Took a bit longer, but by now we can actually argue that machine translation solved. There was always summarization, which was really difficult. It's kind of solved now, right? So there aren't that many hard, like, traditional tasks left. Any improvement that's going to come from these models, and they're going to get better, but that improvement is going to come from squashing even more parameters in there, right? So GPT-4 is going to have like 15 quadrillion parameters. I'm not going to produce that. Nobody in this room is going to be able to do that, right? The only actors that can actually produce meaningful modeling improvements are industrial research labs at the size of Google, DeepMind, Meta, Microsoft, Amazon. So academic research, I think, is going to change. What we can do is we can scratch on it, right? We can say like, this is not working. We can do this investigation. Maybe we can sort of find applications for it. Maybe we can look at other things. One thing that I am very excited about is computational social science. These models are suddenly useful. Before, when my colleagues at Bocconi said like, oh, can we do a research project together? Can you write a classifier that can identify whether this text is informative or entertaining? I said, yeah, sure. Can you please go and label 2,000 examples? I said, well, if I label 2,000 examples, then I don't need you anymore. I don't need a classifier. Then I'm done. That's enough for my interest, right? That's a sample that's good enough. Now we can do that with few-shot, zero-shot learning. So there's a lot more opportunities. Now, as I said, we can talk to philosophers. We can implement models and ideas, right? So I think, is it done? No. But I mean, if yes, then I'm just going to become a medical consultant and use ChatGPT to tell people what their rash is or something. So I think it's not over, but it will change absolutely completely.
Thank you, Dirk. Mark?
Yeah, it's a really...
The mic.
Really good question. I had the same experience that I taught an NLP course and had to throw out most of the content. And I went through a depression of sorts, wondering what we were going to do, because every single research direction that we had, which I was super excited about, from automatically generating ECG reports from the ECGs themselves, the text, or taking protein sequences and describing them in natural language. All of a sudden, there's a model that could do it better than we could do it, and we couldn't actually do much more than just say, oh yeah, we use this prompt with this model that, so even all of the stuff that we teach in terms of data science, we didn't really need it anymore because we have this one-shot learning that is making us all obsolete. But on two things there, I think. One is that the models, I had thought that this was the case, that only the big players could actually build these models, and I've come to the conclusion in the last few weeks, reading some and looking at some models, that that's no longer the case. In fact, the progress continues, and some of the really interesting models are coming out of the research institutions and being scaled right down to the point where we will no longer need supercomputers to actually run them. There are certainly lots of really interesting directions. The multimodal stuff is images and text, still very interesting, although I think that we've got to the point where there's no difference anymore. Well, not that many years ago, computer systems weren't very good at identifying anything in an image. We didn't have that capability. Deep learning came along, and suddenly we could see that there was a cat in this image, or it was a dog, or there were 3 children, or whatever. 5, 6 years later, we started to get really good at doing translation. Turns out natural language is harder than images, funnily enough. And then a couple of years, and then now we're at the situation where the models that were designed for dealing with language actually do really, really well with images, even better perhaps than the original models we had. So there's going to be lots and lots and lots of applications where we'll be able to ingest all sorts of information, maybe in a medical situation where we take all of the patient records and we check what the doctor has to say about the patient, and maybe they missed something. I think we're going to be building amazingly good spell checking systems. They're not spell checking, they're diagnostic checking systems, or prognostic, or I think that with this technology you can see quite the progression from if we, and this is probably, I'm getting into a rant and I shouldn't be here, but I was in another panel today where we were talking to teachers and they're wondering what they're doing. And I was saying, well, I remember going to a library and getting cue cards to try to find when the book was. And then they implemented a computer system, and suddenly we had to learn how to use a computer system. That was pretty cool. We could now find the books. And then the web came along, and we could actually find more content. And then the Wikipedia came along, and there was all this debate about whether or not Wikipedia was a reliable source and all this sort of thing versus Britannica. I don't know if you've ever heard of that, but that's what it used to be, the source. And then we've got search engines came along, and suddenly we had all this sort of information at our fingertips. This is just the next level of that. It's a bit hard to imagine where we're going or what we can do, but when we have devices where the spoken interface in real natural language with every single device, we get any information we need when we want it. I think there'll be lots of problems for us to still tackle somehow.
So you're saying no.
Thank you, Mark. Alfio?
Well, the question
Yeah,
is
let's try really to be concise.
That my answer is every year a discipline or a research topic dies, but from the Middle Ages. There are, in the sense that there are so many, this discussion has been done for so many fields of research in the past. Sometimes it's true, sometimes it's not. The reality, I think, it's not a binary thing. You know, things are transforming one into the other. As Dirk was suggesting before, probably we will start studying something new, some new directions. Maybe our work will change, potentially a lot, in the sense that if by NLP research we mean to build new models for solving classical tasks like translation, question answering, yes. Then the part is over, okay. But yeah. But if the NLP research is something that addresses the problem that in the near future, the knowledge about these models will be more and more required by the society. And so that's a first issue, a big issue. And this discussion proves it, okay? The other thing is that I think that these models can be used for doing an interesting thing, which is we can use those technologies as a mirror of our society. We can use it to understand, from the training process, we can understand something about the kind of data we produce every day. The bias is a perfect example of that. So we can provide technology to social sciences, for example, to study in a different way how the society works. And then, very last thing, is that, in my experience, it's very rare that you have a problem, a real problem, that is solved by just keeping from the shelf a model and apply it to the problem. It's very difficult.
Yeah.
There's no. Also with ChatGPT. I think there are some specific things that we need to do, and there is also another issue that training or even fine-tuning these models is expensive, and energy consumption, stuff like that, which means that probably some research on shallow models or light models is another possible direction. Yeah, exactly.
You want to say?
No. Okay. Yeah, so it's already solved. No,
Okay.
no. People are also working on like making it more efficient to train on hardware that we might have and not just.
Yeah, I wish we had time to talk about the open models and the more parameters the better, which is not always the case. But Gabriella, if you want to end this. So
I answer to the question of is NLP over? My answer is no. I explain why. No, because it's true that we have achieved interesting and important results in defining algorithms that cope quite well with data consuming, content consuming activities, huge contents, for example, machine translation, search engines, summarization. But, and generation of texts, which sometimes makes no sense, as we have seen today. But we have the huge area of language understanding, which may work well in very domain-specific contexts, but in larger scale, discourse understanding, presupposition, and better understanding of the language requires still research, in my opinion. But I have an idea that the key word, not the winner is, but the key word is context. This is a very important word because context is used in our talk today as a linguistic context, words surrounded by other words. But in human life, context means I am using a language because I have an audience of students, colleagues, and so we can use the technical terms. So I am adapting to the context which is constituted by the audience in this case. In other cases, I adapt to context, which is also known as a common sense knowledge that we developed in a whole life. And the computers can do it in a larger scale. So I believe that we still have to define possible solutions about this big problem, which are closer to general AI. We mentioned, not general AI, but specific applications. And so context is the key word, domain-specific understanding, which can be enlarged, and we have still to do. Alfio and Dirk mentioned another things which is related not to the risks, but to the aspects we pay attention to, is energy consumption. Because these models which are based on machine learning consume a lot of energy. And there is a branch of research which is called green computing, which is aimed to find solutions that, as Dirk mentioned, are aimed to define feasible models which work well with less parameters. Last, if I can say just a word, I try to be very synthetic, but I do this in life because with the task to be head of department and other things, I must organize very well my time. A very last was, okay, I've lost. This means that we are all tired. What I was wanted to mention that the energy yes, hybrid approaches. So we focused today on ChatGPT and then on machine learning based approaches, which are of course so important and so powerful because this is a big achievement of science, of research. But if we want to try to combine learning, which is an aspect of human intelligence, with capability to reasoning and to be aware of the context, we have to inject context and inject reasoning patterns into systems. So this is what we call hybrid approaches. And I believe that the future will be, one of the aspects of future research will be in this line. Okay.
Thank you, Gabriella. Okay, we don't have much time for
Let me say something.
We have one question from the audience.
So let me put out a projection. In 5 years of time, we'll not talk about language models anymore. We'll talk about semantics. So I tell you the story. I happen to be an old person here. I have been living through ages of computer science and the way in which things go up and down. I remember when Ivan Sachs, who was a computational linguistic at Stanford, was thinking about a universal grammar, which, by the way, he was also the advisor of my wife, but that's another story. And then I went to see the fifth generation project of the Japanese, like 20 years ago, or 30 years ago, and they were able to translate Japanese to English and back, based on big models, which were a universal grammar. They were not trained. They were essentially built top-down. And I've always been thinking that going top-down is much better than bottom-up. And so you will see that in a little while, the story of going bottom-up, which means being training and learning and so on, will receive another input from semantics, much in the same way as the web has become semantic using let's say the Google Graph and stuff. And this is just a period in which we are seeing the story, and we are seeing the period where AI is strong. And AI is going up and down, and at the same time, semantics is going up and down. But I think the real important aspect of, let's say, understanding is semantics. When it will happen, I don't know, but in 5 years from now, for sure, we will not talk about language model, we will talk about semantic model, because the semantic will strike back. That's my projection.
Yeah, I think
I agree.
It's related to
I
what
agree. It's very
Gabriella was
close.
saying.
It's related to what I told, that we knowledge, okay, in order to understand, because there is no understanding at this stage with these large language models. Human beings need to combine common sense knowledge, reasoning capabilities with what they learn, and all this combined allows to understand semantics and to have an understanding of, And so I agree with this.
Not only semantics, if I may add, also pragmatics and act of speech, the context, that kind of stuff, but I agree, is the problem that will be on the scene and no more the techniques to solve the problem. Probably large language model is a step that can tell us something about the semantics, and but yeah, definitely.
I disagree. These models can explain themselves. I think when we talk about understanding, like when we talk about the model lying, etc., it's an anthropomorphism. It doesn't make any sense to make that statement. We have to be very careful what we use when we talk about the terms knowledge, when we talk about that the model knows something or the model understands something. No, the model is the model. I think these models are incredibly powerful and incredibly able to explain why they are generating the output they are. They are incredibly useful, and for whatever task that they're used, if somebody wants to summarize their homework, or if they want to program a system, or there's all sorts of different uses of these models, and so I don't see semantics as being.
Except that you have semantics, you don't have hallucinations, because you know the real. What is behind the stories, or at least you can fight hallucinations.
No, because the hallucinations are factually incorrect, but semantically they're consistent. So
well, yes, if you have semantic which is at the full power, which is what I think we had in the 90s to some extent, because I was looking at people who were talking in English, and the people were understanding in Japanese. So it was 30 years ago. The thing is that, of course, then it has never took off, this fifth generation whatever project. And then we know we go through what are called the AI winters and the AI summers. So this is an AI summer. But I think in the long range, there will be a debate between doing things top-down, which means having some well-understood knowledge, and doing things bottom-up, which means learning from sentences. And to me, in the end, bottom-up wins. Top-down wins.
I think
anyway, this is what I would like to bet on a dinner in 5 years from now.
Let's meet in 5 years. And
I think predictions are very hard, especially about the future. So if we talk about 5 months ago, I would not have predicted that we sit here talk about these things. I think the categories that we're talking about right now, and I don't have your perspective because in the 90s I wasn't aware that NLP existed. But I think our categories might not even apply anymore. I think in, who knows, 5 years we might talk about completely different ways. I think the segmentation that we see right now, we need to overcome. Linguistics has struggled with that. Linguistics has defined itself as being completely different and separate from psychology, memory, everything. And it turns out language has a lot to do with motor control, with signal processing, with psychology, with memory. So I think these models, for now, they're nice and interesting, but again, if you take away language faculty from them, there's nothing left.
About entity extraction, I'm talking about semantic search. What Google gives us at the moment is an explanation which is no longer a text, is something which is understood. Because this has been the struggle of the people at Google in the last probably 15 years, how to come from a very rudimental semantic model to one which is accepted by everyone. And when you do entity extraction and you do it with 99.999% probability of being right, then you have an entity which is much more than a sequence. And then if you have several entities which explain what you are doing, it is much stronger than sequences of words. So my conjecture is that in 5 years I will win the bet.
Yeah, I'm still going to disagree on the database viewpoint on that.
Yeah.
The machine learning is going to win, unfortunately. And it's going to overcome the hallucination simply by having more data, bigger models, and by having better prompts. If I don't want the model to hallucinate, if I don't want it to state anything that's not factual, or if I want it to cite sources, etc., then I can state as much in the input. So I don't think that there's any necessary benefit of moving to structured data from the natural language. You can say anything you want in natural language. So if we can conquer natural language with these models, it's hard to say that they need anything else.
Okay. Yeah. Maybe you can fight in the department some other time. No problem. Yeah. Just so we are running out of time, I want to ask you this question, which came from the audience, which is even bigger than the previous ones. So the question is: would you suggest to a kid these days that it still makes sense to study computer science at all? Because as you said, we're just scratching the surface of AI. So would you dare suggesting somebody to take this risk? Whoever wants to.
Sorry, but I did not catch the question.
So
would you still study? Recommend people study computer science? I would recommend do whatever you think you want to do. I started out studying linguistics and literature, and now I sit here and talk to you about computer science, and I sit in the business school. So who knows, right? Like, you'll learn some valuable skills. Computer science is a lovely field. So by all means, do it. Is it going to hold up? Now there's a rush. There's a lot of other people who study computer science. If you only do it because it's the new en vogue thing to do, that's the same as studying economics in the 90s or whatever the current trend is. Do it because you love it. Do it because you're interested. It's still going to be there. It's going to wait for you. And maybe you're going to have the solution that brings us forward.
Oh, please.
Mark?
For sure, it's a really interesting question. I think I would say yes, because probably the computer scientists, if anybody, is going to be the ones that are going to understand the future in this area, because it's evolving so quickly. Maybe we end up being computer scientists and doctors at this point because we don't need them anymore. No, I didn't say that. Super interesting. I don't know what I would say. Yeah, it's better to be the ones that understand what all the changes are, perhaps, than being the ones that are just being affected by it.
My answer is that I studied philosophy originally, but since since my PhD is in computer science, I can just stay on the category and say, no, the stupid answer and a serious one. The stupid is, I say from long time now that computer science is becoming a part of the humanities. And the serious answer, which is related to that, is some years ago, I would say to a guy, study computer science maybe because you are interested in computers. Now I would say, study computer science because you are interested in humans. Mm-hmm. That's the serious question, the serious answer. So it's more pervasive. So the people potentially interested is larger, I think. And I suggest it.
Mm-hmm.
Okay. My answer is yes, I would recommend, because it's just a part of a whole complex picture. computer science is pervasive. Computers and computer-based applications are pervasive. What is lacking in people is consciousness. So I would suggest even, I am a little bit provocative, to start explaining children what computers are, what is behind, what are the limitations and the potentialities, because Italy, like in Europe in general, is suffering of a big digital gap for skills in computer sciences, Italy especially. There are a lot of young people who are not well aware of what they are using. So my answer is yes. And I also agree with Alfio, this also helps to better understand human beings, and why not also to try to protect human beings, because if you explain and if you do actions in order to pass the message that you can use technologies in a good way is important. The enemy must be known. So from some perspective of people, that could be, wow, computers, very dangerous, but why? What do you tell me about these technologies? You know. If you know, it's better, no? And if you know, you are more conscious about the potentialities and limitations.
Thank you so much, Gabriella. Yeah, I think we are done, so I want to thank our speakers again with a big round of applause.
Thank you. Thank you to you.